we were graphing equations of lines. Today we're going to actually practice writing them, and then we'll do some graphing as well. But the focus today is actually writing equations of lines in different forms. So first, we're going to find slope between these 2 points, 2, 3, and 4, 2. And then we're going to find some equation, and then we're going to graph. So let's start out here. How do I find slope between 2 points? Well, there's a formula for that, all right? Formulas are wonderful things. Slope formula, remember? If you don't know it yet, start to memorize it. y2 minus y1 over x2 minus x1. So if I am looking for slope here with these 2 points, I would have 2 minus 3 over 4 minus 2, and I get a slope of negative 1/2 if I subtracted correctly. So the slope is negative 1/2, and that's pretty good. Now I have this thing that asks me to use the slope and find the equation of the line through those 2 points. Okay, I could certainly graph this at any time. I know enough information, but let's find the equation of the line. So y equals mx plus b. I know slope. I just found slope. And what other pieces of that do I actually know? Well, I know an x and I know a y. I know a point. I don't know the y-intercept because neither of these have x as 0 in their x-coordinate. So I'm going to plug in just this point. You can pick either one, and I'm going to say 3 is equal to our slope, negative 1/2 times 2, which is the x value, plus b. And I'm going to figure out what b is and then write my equation of the line. So just a little math here, negative 1 plus b, and then add 1 to both sides, so I get b is equal to 4. So the equation of my line is y is equal to slope, negative 1/2 x plus 4. Okay, now let's graph that. Over here on my graph paper, I'm going to label my scale. I'm going to just go by ones, so label it like that. So I have a y-intercept of 4 right there, and a slope of negative 1/2, so that tells me I'm going to go down 1 and right 2. And I can do that a couple times, down 1, right 2, to kind of get a better idea of where my line is going to go. And I should be able to see that those 2 given points, 2, 3, and 4, 2, were on the graph. So 2, 3 is right there. I made it pink. And 4, 2, right there. I made it green. So we probably have the right equation of the line because all of those things kind of just make sense together. So I'm going to go back here and I'm going to sketch my line through those points. And it's easier to make it straight if you have extra points in there, but not necessary because you could use a ruler. Okay, so we have that line that matches this equation that went through those 2 points. Super cool how everything kind of just checks itself, right? I thought so. Okay, let's look at more. So we want to find the equation of the line, again, through 2 given points. And we're going to do this first one on the left in slope-intercept form. So I need 2 things. I need a slope and an intercept. Mathematicians are very literal people. If something is called slope-intercept form, we're probably going to use things like a slope and a y-intercept, okay? So there's our 2 points. Let's find slope. So 20 minus 8 over negative 6 minus negative, so plus 2. So 20 minus 8 is 12. Negative 6 plus 2 is negative 4. So I get a slope of negative 3. And then a y-intercept. Again, none of these x-coordinates were 0, so we'll have to calculate our y-intercept. Pick a point. Pick your favorite point. Doesn't really matter. I'll choose the negative 2, 8. So y8 is equal to negative 3 times negative 2 plus b. Negative 3 times negative 2 is 6. Subtract 6 and I get 2 is equal to b. So equation y equals negative 3x plus 2. We had to find m and we had to find b. Okay, so sometimes slope-intercept form, while it's easy and we're all very familiar with it, not the most convenient. So some of you may remember from Algebra 1 this other form for equations of lines called point-slope form. And point-slope form, again, mathematicians being the literal people they are, if it says point-slope, we're going to need at least one point and a slope to use this equation. So I was given in that example 2 points, but it's a good thing I know how to find slope from 2 points. So I can use point-slope form. So let's find our slope. Negative 6 minus negative 2 and 12 minus 8. So it should be negative 4 over 4, which is a slope of negative 1. Okay, now point-slope form works like this. You pick one of the points, doesn't matter which one, and you plug it in for x1 and y1, and you plug in the slope for m. This y and this x stay as x and y because we need those in the equation. So let's write it. Y, I'm going to use the first point, minus negative, so y plus 2 is equal to negative 1 times x minus 8. That is one possible answer in point-slope form. Another one, somebody else might decide that they want to use the second formula, or the second point, sorry, which would be y plus 6 equals negative 1 times x minus 12. Okay, either of those are correct in this case. Isn't that neat? You could have two different answers and still both be right. The way we can check that to make sure, if you want to simplify both of them, you can find that they are both in slope-intercept form the same. So simplifying to check to make sure is a good idea. All right, last two examples and then you can start your homework. Here we want standard form, so this is our third type of equation that we have talked about with lines. Standard form, remember, ax plus by equals c. So we don't usually start in standard form. We'll start with either slope-intercept or point-slope, and then we'll just kind of rearrange it at the end to figure it out. So I'm given 2 points. Neither of them is a y-intercept, so my go-to is always point-slope form, so I can figure that out. So I'm going to figure out slope kind of quickly. Doing some math in my head, 3 minus negative 2 is 5, and 35 minus 10 is 25. So I get a slope of 1/5. Okay, I'm going to start by writing this in point-slope form because I have a point and a slope. And again, choose your favorite point, doesn't really matter. So I'm going to write y minus 3, I'm going to choose that second one, is equal to 1/5 times x minus 35. And now my answer wants to be in standard form, so I just need to do some rearranging. So I see a distributive property here. So I'd have 1/5 x minus 7. Standard form has all variables on one side, all consonants on the other. So I think I'm going to add the 7 and subtract the y. So I'm going to have 4 equals 1/5 x minus y. And then the last thing, usually a and b and maybe c, a and b for sure, are usually integers, not necessarily rational numbers. So I might just multiply by 5 everywhere. here to make this a standard form equation. So 20 would equal 4, not 4, it equals just x. 5 times 1/5 is x minus 5y. And there's our standard form equation, ax plus by equals c. Okay, last example before you get to work on your own. Find the equation of the line perpendicular to the given equation, but goes through the point 4, 3. So we have our point. Perpendicular tells us something about the slope, so I'm very curious about the slope of this line. That slope is 5. I want the perpendicular line, so I want the perpendicular slope. Do you remember? Perpendicular slopes are opposite, so I need a negative sign, and reciprocal, so I do 1/5. So I'm going to use this point 4, 3 and this slope negative 1/5. All right, point and a slope reminds me that I could use point slope form. So I'm going to do y minus 3 equals negative 1/5 times x minus 4. Okay, these instructions didn't give me any specific formula or form of a line that I needed, so if it doesn't specify, I can be done right now. Okay, that is an equation for the line that is perpendicular to the given line through the point 4, 3. Okay, if it specifies, then you have to do some algebra and rearrange, but if it doesn't, stop when you think you can. All right, let me know if you have any questions.